Let's go over a couple of examples for this week's discussion quiz. Question 1 is multiple choice, and that means we'll put the capital letter that corresponds to our answer in this box. Question 1 states that a bacteria culture starts with 200 cells, and it grows at a rate proportional to its size. If you see that language or something referencing this means the rate at which the population grows with respect to time is equal to some constant k times the population. And in fact, it is this k that we're looking for to answer this problem. Now, this is called a differential equation, and really we know that the solution to it looks like this. P, or P of t, you could write, is equal to P naught times e to the kt. So essentially, can we use this equation to solve for k? So we need to know a couple of things. One, what is P naught? That is the initial amount for this problem. And if you look at the statement of the question, it says we start with 200 cells, and that's what P naught is equal to. We call this the initial amount. So we can fill that in the equation. P, or you can write P of t, is equal to 200 times e to the kt. Now there's another piece of information in this problem. It says that after 9 hours, the number of cells has increased to 1,000. So what this piece of information means is if you put 9 hours here, the output is going to be 1,000. If you write that as a function, that's P of 9 is equal to 1,000. In other words, if you put 9 in place of t, you'll put 1,000 in place of P of t. Let's fill that in. 1,000 is equal to 200 times e to the k times 9. Essentially, putting 9 in place of t tells us, oh, that's got to be 1,000 as long as I put 9 here. We have an equation that we can now solve for k, and that should be hopefully one of these choices here. I'll make a little space by going in this direction, but this is 1,000 is equal to 200, and I'll write that as e to the 9 times k. If we divide both sides by 200, so let's see, I can divide this side by 200 and this side by 200. We now get that our equation is 5 is equal to e to the 9k. How do you solve an exponential equation where the variable is in the exponent? Because the base is e, I'm going to use the natural log function. I'm going to take the natural log of both sides. In doing so, the left is just a number. It's the natural log of 5. The natural log and the exponential function are inverses, so they cancel. What this does is it reduces our equation to the natural log of 5, which is an exact number, is equal to 9k. If you divide both sides by 9, you get 1/9 times the natural log of 5 is equal to k. The units on this turn out to be hours to the -1 exponent, but I'm looking for this value here, and that appears to be choice B. So B is the correct answer, and I'll put capital B in this box. In question 2, we're told that a particle is traveling on a horizontal line, with movement to the right as the positive direction, and to the left, therefore, has to be negative. 0 is going to be right in the middle of my number line. This formula tells you the location of the particle on the number line at time t in seconds. Part A says, determine at what time the particle is at rest. So to figure this out, you have to know, well, when does the velocity of this particle equal 0? Like, that's the thing that we're trying to solve for. And by definition, if you want to know the velocity of a particle and you're told its position, that is the derivative of the position function. So to get the formula for velocity, we'll differentiate this thing with respect to time. The derivative is going to be 3t squared minus 3. So whenever this equation is equal to 0 is when the velocity is equal to 0, and that means the particle for that moment is at rest. So to solve 3t squared minus 3 is 0, we'll add 3 to both sides. Divide both sides by 3. That should have been a 2. And you can take the square root of both sides, and you actually get two solutions. T is equal to plus or minus 1. However, we're told that time is defined to be positive, and therefore we only have to consider one solution, and that is t is equal to 1 second. And this is the answer that we're looking for. At 1 second, this particle is at rest. So you could put, t equals 1 second like this. That would be fine as well. But in either case, at 1 second, this particle is at rest. Part B asks, what is the total distance traveled by the particle between 0 and 3 seconds? And the thing to note here is that at 1 second, the particle actually stops. What I'm going to do is I'm going to copy down the position function, which is s of t is equal to, that was t cubed minus 3t, and I'm going to evaluate it in a table of values. And the times that I'm going to check are 0 seconds, the time where it's at rest, which is 1 second, and then 3 seconds. If you put 0 in place of t into this formula, s of 0 is 0. If you put 1 in place of t, that's 1 minus 3, so that's negative 2. And then if you put 3 into this formula, that's going to be 3 cubed, which is 27, and then you have 27 minus 9, and that simplifies to 18. So how far did this particle travel over that first 3 seconds? It might be helpful to think about this on a number line. So at time equals 0, it's at 0. At time equals 1 second, it's at negative 2. And at time equals 3, well, this is going to be scaled nicely, but it moves all the way over to 18. So again, that is when time is 0, it's right at the origin. When time increases to 1 second, when the particle is at rest, it moved all the way over here. So it moved this distance. Then between 1 and 3 seconds, it's here and it moves all the way over here. And that's where it ends up. So this particle starts here for 1 second and goes this way, and then turns around and goes this direction. What is the total distance traveled by this particle? Well, this distance is 2. This distance is 2 plus 18 more, that is 20. So the answer should be 22. If you want to use equations and formulas to simplify this, I would write it as follows. It's the distance given by the absolute value of s of 0 minus s of 1 added to the absolute value of s of 1 minus s of 3. Before simplifying this, just think about what it means. If you subtract s of 0 and s of 1, because it doesn't change directions here, that gives you the distance, and the absolute value is present just to make sure that your answer is a positive number. The same thing is true over here. This is the distance between 1 and 3 seconds because it's always moving in the same direction, and the absolute value is here just to ensure that you have a positive number. So filling in our work, s of 0 is 0, and we're subtracting s of 1, which is negative 2. To this, we're adding s of 1, which is negative 2, minus s of 3, which is 18. This is the absolute value of positive 2, plus the absolute value of negative 20. That is 2 plus 20. The answer is 22, and that's 22 feet.